In this video, we're going to cover the basics of wiring diagrams or schematics, and then we're going to talk about soldering right at the end. Common symbols that you're going to be dealing with. Starting in the top left, we're going to look at a battery. Battery is almost always going to be drawn this way, the alternating long and short lines. Long line represents the positive plates in the battery, the short lines, the negative plates. So as you look at there, you can tell which side is the positive terminal. Underneath that, we have a couple different symbols for ground. Then the fuse, a couple different symbols there. Circuit breaker, you can see, is definitely different looking than from the fuse. We have a normally open switch. If it was a normally closed switch, the line would connect the two dots. Then we have a grommet. Grommet is where the wires are going to pass through the firewall or into the door, and there's no connector there. It's going to be a rubber grommet around there to protect the wires from cutting through. And the manufacturers are going to designate that with a P for a pass-through grommet. They can't use a G because G is going to designate a ground. Have a gang switch, bottom left. The dash line showing you that. Keep in mind that is one piece. Physically, you cannot move one of those switches without moving all of them together. Top center, few different symbols for lights, the way that they're drawn. And the engineers or whoever drew the schematic, how they choose to draw it. Underneath that is a dual filament bulb, which would be used like for a tail light, brake light, or up in the front if it was a turn signal, park light. One filament is brighter than the other one. Underneath that's the connector. Looking at the one on the left, you should be able to identify which side is the male terminal, which side is the female. If you can't, you may want to consider taking an anatomy class. To the right of that is the Nissan way of doing it. The square that you're looking at right in here, that's going to be your male terminal. That covers over is the female terminal. And Nissan and Subaru are about the only manufacturer that their connectors, they designate the numbering for each side of the connector. This one, your male terminals, if you were to unplug the connector and look at it, the male side would be M4, the female side would be E5. The M would be the main wiring harness, E would be the engine wiring harness. Underneath that is the splice, where wires are soldered together. It's just a black dot that's going to designate where the wires are spliced together. And there could be anywhere from 3 to as many as they want to splice in there. We have the diode symbol. Underneath that is our transistor, the PNP and the NPN. Remembering that the arrow is going to designate if the arrow is pointing in permanently or if the arrow is not pointing in. So identifying the leg that is the base, which is the top leg right there. On that PNP, we need to ground that leg, make it more negative than the emitter in order to turn it on. NPN, we need to put a voltage to the base in order to turn it on. Top right, we have the LED. It may not have the circle on there, it may have one arrow, but it's generally going to be drawn like that. We have a resistor. Then we have the variable resistor, which would be something like a potentiometer or a thermistor that's going to change resistance with temperature. Underneath that, the coil. So this is our electromagnet, maybe a solenoid, maybe part of the relay, maybe part of a sensor. But when you see that symbol, the wire's wound around there a bunch of times. Next, we have a capacitor symbol, and then we have the heated element. This would be like for your heated seats, rear defogger, or something like that. Electric heater, and then Zener diode. This is not all of the different symbols that you're going to be seeing. If you're looking at a wiring diagram, you see a symbol that you don't recognize, the manufacturers will provide a legend that you can look it up and find out what that represents. Then we get to wire colors. Most of the automotive wiring is solid color with a stripe. Looking at some of the wires over here, we have yellow with a red stripe, yellow with a black stripe, red with a white, blue with a red, red with a blue. Manufacturers will abbreviate that when you're looking at the wiring diagram. So you may come across a BL. Well, is that black or is that blue? You got to find the legend to figure out what it's supposed to be. Some of the manufacturers use unique ones. So Nissan, if you're looking at theirs, you'll find a SB wire, which any other manufacturer, that would be a light blue, but Nissan is sky blue. Several of the Asian manufacturers, they use the L to designate a blue wire, so the B would be black, BR brown, L is blue. When you get the whack put in there, this is going to be our red with a white stripe, and then yellow with a gray stripe. But again, each manufacturer does it their own way. There's no standard for it. Then you have the German. They're going to use the German word for the color, which if you speak German, this would be easy for you. For people like me, it's not. WS, yeah, I see the W. I generally think of white, but it's Weiss. Black is Schwarz. I'm so tempted to put a T on there. That's the German way of doing it that you're going to find on a lot of the European cars that are imported over here. Again, you got to look up that legend. We have our cursed dashed line. That means so many different things. Top one here, they're showing you that same gang switch. On this one here, this dashed line, which is showing us the gang switch, we have this dashed line, goes all the way around the headlight switch, which is telling you it's incomplete. This headlight switch does more than just what they're showing you here. It's probably going to be the dimmer for the IP lights, but that's not part of this circuit. We have another dashed line right there, which tells you connector C1. This comes cavity A, and this one comes cavity D, so that tells you it's part of the same component. Down here, same thing. We have these two fusible links, the dash line going between there. What that means is this spot on the car, which is on your starter solenoid, it's going to have this wire plus these two fusible links. Bottom line, careful of the dashed line. It changes meanings depending on the application. Last one on here that you're going to find, and that is that symbol right here, which I'm showing you. That's option. On this example, you got to know the car that you're working on. If it has the optional ABS and daytime running lamps, then there's a splice on that wire. If it doesn't have those, this wire is just one single wire that goes all the way down to here. Now let's get into starting to read this. When you first look at this wiring diagram, as students look at it, they look at this and they think, okay, there's two light bulbs wired in parallel. This is not two light bulbs wired in parallel. This is actually two separate circuits. Up here at the top, we have battery voltage. Down at the bottom, we have ground. This is a Valley Forge style schematic. This is found in a lot of the books that are used for training. And there's a ton of mistakes on here that they never bothered to fix. So we're going to come across several mistakes that we'll be looking at. The other thing is you'll find some mistakes in the manufacturer's wiring diagrams, but generally they will fix them. And some, the mistakes there, and you'll never know the mistake. You can work on it, you can read it, and go work on the car. You'll never know that there was a mistake in there. First mistake, got a junction block right here. Junction block's going to show a whole bunch of fuses, but they're telling us this junction block is one fuse. There should be a dashed line around there, like there is here. Our instrument cluster is more than just two light bulbs. Same thing, our junction box is more than just one fuse. So there should be a dashed line here. The other thing is they're telling us this is hot and start, run, and off. Your lights are not on in the off position. That off right there is a mistake. This is hot and start and run. Turn the key on, and we're going to have battery voltage down to here. These lights do not stay on anytime the key is on. That means that the ignition switch is not the control for this. When we can go from the fuse to the load and there's no switch in there, that tells us this is ground side control. And that's important when you're going through and diagnosing. If I'm ground side control, that means I'm going to have battery voltage here. I'm going to have battery voltage here after the load. The only time this is going to go below battery voltage is when the switch actually closes. It's on there. We have power coming down. We have a splice here. I'll come back up here to this connector. They're not really showing you the male connector other than it's inside there, so the male connector is part of the junction block. This is connector 6 or C6. And this is cavity 10. If you go to the connector, the manufacturers will typically put the numbering or lettering, whatever they have on there. And I took this one and blew it up so that you can see it. This is a 7-pin connector. You can see this is number 4, this is number 5, and then you're going to have 6, 7. On the bottom side here, we would have to look at the other side to know if this is 1, 2, 3 going this direction, or 1, 2, 3, and then turns back around. Got to look at the terminal, and when you find the terminal, the cavity, then look to make sure the wire color matches with the wiring diagram. Unfortunately, this wiring diagram doesn't tell us wire colors, but this is just for training purposes. From C6, we're going to come to splice 213. The only reason that they number these splices and these connectors, and you see down here we have connector 110, that's how you're going to find it. There's going to be a component locator that you're going to go to, and they're going to show you either a drawing of connector 110, the area that is located on the car. They'll give you a description under the dash, driver's side, next to the steering column. Some manufacturers, such as Honda, they actually give you a photograph to look at so you can see it. That's awesome. I love to have that photograph because it just makes it a whole lot easier. There's our power coming to here, and then we get to actually having two separate circuits. Take a look at this circuit first of all. Power's coming to this light bulb. It is shared with that other light bulb. That's splice right there, telling us that. Comes down to this circuit as connector 1, cavity 5. Then it comes to connector 110, cavity 7. Comes down to connector 101, cavity 4. And then gets to our switch, which our switch has the male terminal, and this connector just plugs right on there. Nothing down here as far as a wire, which means it's self-grounding. Where this screws into or bolts into the block, that's the ground. I should have full battery voltage right down to here until that switch closes, which this is another mistake right here. That should be a normally closed switch, key on, engine off. That switch is going to be closed. It's not going to open up until oil pressure gets up to 4 to 7 psi, somewhere in that range. If this is off all the time, the light will never come on. I need to go through and diagnose it. Probably the first place that I'm going to start on here, and backing up a little bit, when you read in some of the wiring, they're going to tell you start your diagnosis in the center of the wiring diagram. I want you to come and find connector 110, do your testing here. If you find full battery voltage here, that tells you everything before this point is good, so the problem has to be after that. The problem is, where's C110? I need to go back into the service manual. I need to find the component locator, find C110. It's up underneath the dash, driver's side. I look up underneath there, and there's 23 connectors up underneath there. So then I have to figure out which one of those 23 is connector 110. So then find cavity 7. Let's do it easier. Find the easiest spot on the car. This oil pressure switch is on the block, normally close to the oil filter. That's where I'm going to go. Get to this, I'm going to unplug it. Once I unplug it, I'm going to then take a jumper wire and short this wire to ground. I'm going to come up and look. Did the light come on? If it did, everything is good right to here. I'm going to replace this oil pressure switch. The other thing is, that oil pressure switch, that lives in the harshest environment. It is the most likely component to fail. That's another reason that it's a good place to start. Here's our other light. This one is significantly more complicated. We have power coming in to right there. No switch in between there, so again, it's ground side controlled. Then come down here, and I've got 1, 2, 3, 4, 5 different things. Looks like that can control this light. We'll start with this one on the left here. This is the ignition switch. Number 1, they tell us right here, is the start position. Now what's strange about that is this up here is the ignition switch, and this down here is the ignition switch. Both power and ground come through the ignition switch. If you notice on your car, when you go to start it up, a bunch of lights come on the dash. This is part of a bulb check, which when there was only 2 or 3 bulbs, that was good. But now that there's 15 or more bulbs on there, you're supposed to notice tomorrow morning that there was only 14 lights that came on instead of 15. The idea is good, it's just not very reasonable. When you turn the key to the start position, it provides ground, turns the light on. There's one switch. ABS. This is our ABS module that can turn it on. It's going to turn it on when a DTC is set. Daytime running lamps, like what in the world does that have to do with a red brake warning lamp? And I know it's the red brake warning lamp because it's part of the park switch. It doesn't actually. If you have the park brake set, when you turn the key on, It's not going to turn on the daytime running lamp. The only thing this computer does is monitors that circuit. If it sees battery voltage, it knows the park brake is not set, daytime running lights will come on. If you start it up, there's close to 0 volts here, it's going to conclude the park brake is set, daytime running lamps will not come on. Come to this one here, our brake fluid level switch. There's usually a magnet that floats inside of there. If it gets close to this switch, it's a little reed switch. Contacts will close, turn our light on. And then the park brake, whether it's in the center console or on the floor, under the dash, left side, that can turn the light on also. In this scenario, we will say that the red brake warning lamp is on all the time. Customer brings it in, they're saying they set the park brake, they release the park brake, light stays on. Where would you start your diagnosis? Well, for me, I'm going to start at the ABS. I'm going to go grab a scan tool, plug it on there. First of all, I'm going to check for DTCs. If there's a code that's set, computer turned on that light, we need to diagnose an ABS problem. If there's no code, I'm probably still going to look at the data list, and I'm going to look to see if the ABS control module is commanding the light on for some reason. If it's not commanding it on, I'm going to figure, okay, this is probably not where my problem is. Next place I'm going to go to, where's the easiest place to get to? Usually going to be this brake fluid on the master cylinder. I'm going to pop the hood, look over there, unplug the connector at the brake fluid switch. If the light goes off, check the brake fluid level. If the brake fluid level is good, there's something faulty with the switch, but I know that it's there. Next would be the park brake, and I'm going to try to get to that. If it's in the center console, I got to tear some stuff apart to get down in there to it. If you go through and unplug the ABS, unplug this brake fluid, unplug the park brake, and the light's still on, well, now this wire somewhere is shorted to ground. Now you got to follow along the wiring loom until you can find that there's physical damage. Wires rarely get damaged inside of the wiring loom. Usually they get damaged where they come out of the wiring loom. So again, that's where I'm going to concentrate my diagnosis in trying to find that. Soldering. Make sure that you use a rosin core solder. While you're doing it, the rosin is going to help clean the wire and help the solder to stick there. First thing we're going to look at is this solder job right here, which this is not a good solder job, at least not for the car. When you try to insulate that, that thing's going to be sticking out. It's going to want to rub against something. It's going to rub through and then short out. This one here, again, you will have many tell you that this is a good soldering job. They got lots of solder. They got good penetration. You can see the strands of the wire. That's good. They have way too much solder on here. You can see where this insulation is burned on both sides. That means the heat came out to here, came beyond where the wires are wrapped together. A wire loses its ability to flex. You need to keep the heat contained within this area that's wrapped. What's going to happen is this is going to be subjected to vibration, to flexing. Where it got hot, that wire is going to break because it became fragile. Down here at the bottom, this is a good one. We have the solder just at one spot right in here. I flex the wire here so you can see that this is still flexible where it's wrapped. On this other side too, the wire is wrapped. It's still flexible. So the heat stayed within the area that was wrapped. This is a good job. So first thing that you want to do, wrap the wires together. So wrap one side and wrap it tight. And you'll see it comes apart. So after you wrap the one side, wrap the other side. Now that wire's together. When you're done wrapping, that wrap should be about the same size of the insulation. Now when you get the shrink tube or the tape on there, there's nothing poking out. When you get your solder, get a puddle of solder on your tool, put that on the bottom side, your solder on the top side. Once it gets hot, it'll go right in there. As soon as the solder goes in there, you're going to pull it away and your heat stays right inside there. Just put the solder on there for a short time.